All right, welcome back. We are in 6.8, which is the distance and midpoint formulas. So we'll start by looking at the Pythagorean theorem. Which deals with a triangle, a right triangle. If I have a triangle, it's a right triangle if one of those angles is 90 degrees. And if that angle is 90 degrees, then if I have a side length of A and side length of B that touch this 90-degree angle right here, and then C is the long part on the opposite end, then we'd say this. The length of C squared is the sum of the squares of A and B. Well, A squared plus B squared equals C squared. Right? So the next thing that we would also want to talk about is the principle of the square roots. That's not to say the principal square root, but it's the principle of square roots. Maybe not the best name. And that says that if x squared is equal to a, then either x is the square root of a, or x is the negative square root of a. Right? For example, if, say, x squared is 9, x could be either the positive square root of 9, which is 3, or x could be the negative square root of 9, which is negative 3, which makes sense because 3 times 3 is 9, negative 3 times negative 3, also 9. They both fit, right? They both work. So we have those two things. And we can use this, both of them really, but we're going to use that Pythagorean theorem to find the distance between 2 points. Let's call this point, I don't know, P, and this point Q. A lot of times you'll see this P, Q with a bar over it. That's the length, right? But that's just the length of C, and I know that C squared is A squared plus B squared because of the Pythagorean theorem. And so let's take a look at a problem. Let's say we'll find the length of C. If I'm given a right triangle, and let's call this, well, this one's 3, let's call this 4, and we want to figure out what C is. C is the value on the opposite side of that triangle, so I know that it's 3 squared plus 4 squared equals C squared. That's the Pythagorean theorem bit. I'm going to evaluate the squares, the 3 squared and the 4 squared, and then add them together. So 3 squared is 9, 4 squared is 16, and the sum of those things is 25. But now I'm going to use that principle of square roots, and if C squared is equal to 25, then C is either equal to 5 or C is equal to negative 5. Right? In the context of this problem, it doesn't make sense to have a negative distance on a leg of a triangle, and so my answer is C equals 5 by context. And that's what we'll use when we're talking about distance. It doesn't mean anything to have a negative distance on an object, right? I can't have a triangle with a negative length of a side. We kind of can when we get to trigonometry. That just kind of talks about the orientation of the triangle rather than the actual length of the, or one of the legs of it. But for now, we'll just talk about only really having the positive values, right? So let's take a look at a problem. Oops, my bad. If I have a these are all word problems. I'll type it. There's pictures with them. I wonder if I have this book on electronic. No, that's all right. All right, so I'll just kind of draw it. Bear with me. We have a baseball diamond and home plate down here. That's my beautiful home plate. And then here it says, I'll type this part so that we can read it. A base, okay, maybe a baseball diamond is a square with sides of length 90 feet. Suppose a catcher fields a ball while standing on the third base line 10 feet from the home plate. So what we have so far is the catcher has run over to the third base, towards third base. He's on the third base line and he's gone 10 feet. The baseball diamond itself is a square. Each of these lengths is 90 feet. Right. So that's really all we have so far. And then the question, how far is catcher's throw to first base? And then it asked us to give an exact answer and then estimate. Okay. So the exact answer means if you have the square root of something that's not a nice square root, you just leave it, you simplify it as much as you can. But to give the estimate, you're going to plop it into a calculator and estimate that value, right? So what I know is that this triangle that we've created by the catcher running 10 feet, it's a right triangle because it's a square, and so this at the home plate is the right angle, right? I know that the value of the little teeny tiny leg of this triangle is 10 feet, and I know that this leg over here is 90 feet. And so the question is, how far is that throw? So we just throw it into that Pythagorean theorem. Don't do that. And that is 10 squared plus 90 squared is going to equal to however far he has to throw it. We'll call it c squared. 10 squared is 100 plus 90 squared is 8,100. And so I add those together. Let me just move up a little bit here. I add those together and I get 8,200. 8,200 is equal to c squared. And then I square root it. Again, I'm only interested in that value. Mathematically, it's the positive or negative square root of 8,200, but I don't care. I just want that positive value. So I would say this, that c is equal to that positive square root of 8,200. Can I simplify this? Yes, because 8,200 is 82 times 100. So I know because of this 100, I can take a 10 out, right? So I can write this as 10 times the square root of 82. But can I simplify it further with 82? Maybe. I don't know. Let's find out. I'm going to take 82 and factor it. It's divisible by 2. I know that. And I get a 41 And 41 is a prime number, so I'm done. I can't factor this anymore. There's no more factor pairs to pull out of a square root. So my exact answer is this. Okay. If I want to evaluate this, I'm going to pop it into a calculator. It'll take me too long to grab a calculator and throw it on here and share it. So try it at home. Just take 10 and multiply it by the square root of 82. And you should get somewhere around the neighborhood of 90.55 feet. Not a humongous difference, but that's how far it is. A guy wire, which is just the like at the end of a telephone line or an electrical line, it's the last pole in that line gets kind of fastened to the ground so that the wires don't pull it. So that's a guy wire. But we have a guy wire, the base of a guy wire is 15 feet from the telephone pole that it anchors. How high up the pole does the guy wire reach? Oh, there we go. I was like, that's not enough information. The base of a 40-foot guy wire. There we go. Now it's enough information. So we have this wire. We have some telephone pole sitting out there. You just draw the picture. We've got this telephone pole out there. The electrical line goes off in one direction, and then a guy wire just anchors that thing down into the ground, right? And so I know now that this guy wire itself is 40 feet. And I know that it is 15 feet from the base of the pole. And so then the question is, how high up the pole is this thing? But again, it's a Pythagorean equation here, but I'm asking for one of the legs that touches that 90 degree, right? One of those legs is part of the sum. And so I'm going to just label this as, let's call it B. The equation is 15 squared, right? The squared of one of the sides touching the 90 degree plus the other leg touching the 90 degree is equal to the other one squared, or the value opposite the 90 degree squared. So now I have to solve for B squared. So I'm going to just take this 15 times 15 is 225, maybe. I have to cheat. I think I'm right, but I'm going to cheat. Is indeed 225. Plus B squared is equal to 40 squared is 1,600. And so I'm going to subtract this 225 to isolate the B squared. So I've got B squared by itself. That equals 1375. And therefore this B is equal to, again, it could be the positive or negative. It doesn't make sense to have a negative value here. So I'm only interested in the positive. It's the positive root of 1375. I don't know what that is. It might be able to simplify. So I'll try it. 1375 I know is divisible by 5 because it ends in a 5. And that leaves me with, I don't know. I'm not doing this in my head. 1375 divided by 5. That leaves me with 275, which is divisible by 5 again. So 5, and that leaves me with 55. 55 is 5 and 11, and so those are my primes. I can see I can pull out a 5. I have to leave a 5 and an 11, so I multiply those back together, and that's 5 root 55 as an exact answer. What's my estimate? Well, I just plug that into a calculator, and in this case, I get, this is approximately 37.1. It's like 37.08 something. Good. Let's look then at if I have still a picture here real quick. There we go. All right. Now, if I have 2 points, let's say I want to find the distance. Let's say those guys, right? We're going to look at this on a graph and kind of walk our way through it. So I'm going to plot those 2 points. 2, 3 is there. And -3, -3 is there. So really, I'm asking about the distance between those two. How do I make that? It did it before. It made a nice straight line. Why isn't it not? Why are you not responding? There we go. I think if I hold shift, there's something funky. Hey, look at that. It's a straight line. So I want to find that distance, right? And it should be pretty clear that I can create oh no, why is it being all goofy on me? What are you doing? Why do you hate me? Shift and hold that line there, yay, and shift and hold this line there. Clearly, I can make a 90-degree and turn this into a right triangle, right? And I can just count. Well, there's 1, 2, 3, 4, 5 is the distance of this guy, and I've got 1, 2, 3, 4, 5, 6 over here, right? And so clearly it's 5 squared plus 6 squared is equal to, let's call this value c, so c squared. How do I get 5 and 6 though? Well, 5 is the difference between the x value of my rightmost point, right? 2 and -3. So if I take 2 minus -3, that gives me 2 minus -3 is like 2 plus 3, that's 5. And likewise, if I do my y values, the difference between this top guy, which is 3, minus the bottom guy, which is down here at -3. 3 minus -3 is like 3 plus 3, that's 6, right? And so I don't really need the graph. The graph helps me understand how this works. But what I really need to do is just find the difference between my x values and find the difference between my y values. And those are the lengths squared that you square to get the square of the straight line distance between the two of them, right? So all of that, if you remember it, great. If you don't, that's okay. All of that just merely justifies I'm going to start calling it D instead of C for distance, right? But A was just the difference between my X values. So I'm going to say the X value of 0.2 minus the X value of 0.1 and square it. And then B, I'm going to say is just the Y value of 0.2 minus the Y value of 0.1, and I square that, and that's D squared. And then further, if you want explicitly a distance formula, you just square root both sides, and so we have this. And that's one you should know, right? So let's use it. Actually, I'm just going to yoink. Same question. Find the distance between the points 2, 3, and negative 3. Negative 3, I'm going to plug it into that distance formula. The distance is the square root of x2. So call one of these points x1 and y1, and one of them x2 and y2, and then just plop it in here. X2, as I've written it, is negative 3 minus x1, which is 2. That gets squared, plus y2, which I've got is negative 3, minus y1, so minus 3, and that's squared. We can see then we've got d is equal to the square root of, that's negative 5 that gets squared. Negative 3 minus 3, that's minus 6 that gets squared. The negatives are inside those parentheses, so they get squared out. They get squared out. So that's 25 plus 36, or then the square root of 61. I can't do a lot with 61. I think it's a prime, but I know I can't simplify that, and that's it. That's all I've got. If I did it the other way, and pictorially, I've got this 5 squared plus 6 squared equals c squared. You can see that turns into the same exact thing, because I've got then 25 plus 36 equals c squared. But 25 and 36, that's my 61. And to get rid of the squared, I'm just going to square root each side. And I get the square root of 61 in either case, right? But this means that we don't have to draw stuff out, right? Find the distance between these 2 points. Once again, just call one of them x1, y1. And the other one x2, y2. And then know your distance formula. The distance is the square root of x2, 4, minus x1, 3, squared, plus y2, 7, minus negative 1, and that's all squared, all under the square root. So 4 minus 3 is 1, so that's 1 squared. 7 minus negative 1 is 8, and that gets squared. So I have 1 plus 64, and that's the square root of 65. Can't simplify it, right? 65 is divisible by 5, but I get, what, 13? So I can't pull any factor pairs out of the square root. That's the best I can do. Evaluating that, estimating that gives you 8.06-ish. That's what these squiggle marks mean. That squiggle mark means approximately. It means you've rounded it off at some point. Okay. So let's look then at the next thing, which is the midpoint formula. And if I have two points, I'm going to do not 8. Let's go 4. Negative 5. Right. I'm going to draw these. I want to find the midpoint of these two in particular. Right. So I'll plot them. 2, 3 is right here. 4, negative 5 is here. So I'm essentially saying somewhere between these two is the exact middle. But where would that be? Well, we're talking about having some sort of place where if I cut it, the distance here is equal to the distance here, right? But it really makes sense that that point would kind of be in between the two x values. The x values are 2 and 4, so it would make sense that that happens at 3, the average of those. And then if I average my y values, 3 plus negative 5 is negative 2. Divided by 2 to average it gives me negative 1. And in fact, that is that point. And it really looks like those two values are equal. And they are. And so the midpoint is simply that. It's averaging the x values, averaging the y values, and you have a new point. So that is to say, I have these things. The average x value is, we'll call it x1 and x2, but I take the two of them, add them together, and divide it by 2. And then likewise, the average y value is y1 plus y2 over 2, right? And so then the midpoint is those two values. It's that x1 plus x2 divided by 2 as my x component, and then y1 plus y2 over 2 as my y component. And that's it. This is something you'll want to know. Write it down in your notes. We'll use it, but definitely know it. All right. We're going to find the midpoint of these two. So once again, I'm just going to use each of those formulas. The midpoint for x, which you can call x bar, is a lot of times what you'll call it. But that is negative 4 plus negative 9 divided by 2. So that's negative 4 plus negative 9 is negative 13 over 2. I can't simplify that, so it's that. If you like, you can put it as a mixed number. I don't advise it because mixed numbers, are terrible. The decimal's not bad, right? So negative 6.5. And then my y average, which is also like a y with a bar over it, is the same way of saying average. Is my y values. So 7 plus negative 12 over 2, the average of those guys. So I've got negative 5 over 2. Once again, I can't simplify this. I can turn it into a decimal, and so that is negative 2.5. And that's my midpoint, is the x average, comma, the y average. Done. And we can, again, verify this. Not on that graph because it's too small. Did I have a 12? 1, 2, 3, 4, 5. Why did I do a 12? There's one with 12. Close enough. Hey, and it's humongous. So I'm going to try to verify that this is true, just visually kind of looking at what's happening here. I have the points negative 4 and 7. Let's do this in, I don't know, orange, gold, whatever. Negative 4, 7 is there. Negative 9 and negative 12 is off the chart, but just by 1. So I'm just going to plop it down 1 below it. So negative 9 and negative, oh no, that's dumb. 6, 7, negative 8, negative 9, negative 10, negative 11, negative 12. It's not going to be great because I had to extend the chart down to the negative for whatever reason. But that's all right. So drawing the line between the two of them. There. The point that we got was negative 6.5. So negative 5, negative 6.5 is here. And then negative 2.5 is there. And it certainly is a point on the line. That's good news. And it certainly looks like those two distances are the same, right? Looks like is not good enough to prove anything, but we're not proving it. We're just kind of seeing what it looks like. Right? The formula is solid. We just want to kind of visually convince ourselves that is true. And that's it for this section. So thank you, and I will see you guys back on Monday, the 3rd, something, the 30th. All right. Thanks. Bye.